Hello. My name is Lonely, and this is my submission for homework for the ray tracing graphic homework. So if you see right here, this is a result I got from running the code. This is 1980 by 1080. It took me roughly around 40 minutes to render this image in Java code. But yeah, this is the result I got from it. So let's go over the code really quick. See, okay, so render task. The first part that I basically did is I modified the render task constructor. The render task constructor is modified so that it can include the arena light parameter, allowing each thread to access to the light source for shading calculation. So let's see, this light equal light. Here is the thing I kind of add right there. Is store the arena light object in the render task instance so it can be used for like shading calculation. And then the next part I work on is the compute direct lighting. The compute direct lighting method just basically calculate the direct lighting at a given intersection point, taking into account like soft shadow. It casts multiple like shadow rays to the light source and average the result to determine the shadow intensity. Let's see, the num shadow sample and in unblock. So the num shadow sample is the number of shadow ray to cast. So in this case, that'd be 16 ray. And the unblock just basically count how many shadow ray reach the light source without being blocked. So that's why I set it 0 here. And this for loop, right, this part, the light sample is just a random point on the light source generate using the sample method. And then the shadow ray dir right here, it's just the direction from the intersection point to the sample point on the light source. Then the shadow ray right here, it's just basically a ray starting at the intersection point and pointing toward the light source. Similarly, this if statement just if the shadow ray, if the light is not blocked, is check if the shadow ray intersect with any object before reaching the light source. And if it does not, it's just basically unblock. It's add increment by one. Unblock right here. Yeah. And then the shadow intensity, that's just the fraction of the shadow ray that reach the light source. It control how much light reach the point. And then, oh wait, I forgot to highlight this part too. So let's see the vector tree light direction, just the direction from the intersection point to the light source. Diffuse, double diffuse is just the diffuse component of the lighting calculated using the dot product of the surface normal and light direction. And then the RGB, that's just the intensity of it. Let's see, and finally is the arena light. Let's see. The arena light class just basically simulate the light source with a physical size. In this case, I make it like a disk. This allow for soft shadow, where shadow have smooth edge instead of like sharp boundary, like the original code. The position right here is just the center of the light source in the 3D space. The normal is the direction light is facing, and then the radius is just how big the size is. Then the random direction here, just generate a random direction in the plane of the light source. It's just using math random, yeah, to ensure that the direction is random within like a unit circle. And then tangent and by tangent. Tangent here is just a vector perpendicular to both the light normal and random direction. And by tangent it's just a vector perpendicular to the normal and tangent. Basically completing like the local coordinate system. The 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 R here is just basically the radius of the light size, and the theta here is just the random angle around the light source. And then this offset here, just basically a vector representing like a random point on the light source calculated using the polar coordinate. And then it will return the position, which is just return a sample point on the light source by adding the offset to the light center. And that's basically all I did for this homework. Thank you.